All right, welcome everybody, and thank you for joining us today for our digital Q&A session with Matthew Willson. Before we begin, I'd like to acknowledge that I'm speaking to you here from the traditional lands of the Kaurna people. I recognise their connection to the land, sea, and to the night sky, and I'd like to pay my respects to their elders past, present, and emerging. And I extend my respects to all of those Aboriginal and Torres Strait Islander peoples joining us here today. My name is Tegan. I am one of the space communicators here at the Australian Space Discovery Centre, and today I am assisted behind the scenes by Amy. If you have any questions during our chat today, please submit them through the Q&A feature on the meeting or ask your teacher to send them through for you, and Amy and I will pass them along to Matthew. One last piece of housekeeping. Our session will be wrapping up today at 2:45 p.m. Australian Central Standard Time, but we invite you to stop into the Australian Space Discovery Centre or drop us a line via the contact details on our website if you want to know more about space. So today our guest is Matthew Willson, joining us from Southern Launch. So Matthew, what have you been doing?
Hi, thank you for that introduction, Tegan. I'm, as Tegan said, Matthew Willson. I work at Southern Launch. I am a modeling, simulation, and analysis engineer, which is a bit of a mouthful, but basically means I do 6-degree simulation trajectories and do a lot of simulation analysis for space launch and re-entries these days. So that's currently what I do at Southern Launch.
Would you like to tell us a little bit about yourself and some of your interests?
Yeah, so if you could head to the next slide. Awesome, thank you. So I graduated from the University of Sydney in 2021 with an aeronautical degree in engineering with the space major. So the space major basically means that you get to do a couple extra subjects that are directly to do with space. So you do rocket launches, you do interplanetary missions. It's a really, really cool degree. I highly recommended it. It's pretty cool. So there's me on the right there with my parents, very happy with my degree after 4 years of lots of fun. In the bottom right, thank you. And so that degree and the work that I did led me to the job that where I'm at Southern Launch. And so those 3 pictures on the bottom are me. The one on the left is the SR-75 launch. The one on the right is the VSO-2 rocket that unfortunately didn't get to launch, but we're hoping that it will be able to launch sometime in the near future. And on the right was the successful SR-75 launch. So that was taken by our fantastic drone operator, Christopher Norton, who got that stunning picture of it just leaving our mid-range launcher. So that is a awesome picture taken from a moment in my life that I will never forget.
Yeah, incredible photo.
Yeah, it was well done. So if you want to hit the next slide, that'll go to my hobbies. So this kind of tells you who I am as a person. So obviously I'm very interested in rockets and space. I have been since I was about 11 years old, and I read Andy Weir's The Martian when it was a self-published book. It was free on Amazon. There were spelling mistakes and lots of errors in it from his, self-publishment. He wasn't a proper published book. And it was the greatest book I ever read. And I was like, I want to do exactly that. And so that, being 11 years old, I was like, right, this is how I'm going to set my life up to do the role that I currently do. Probably my second most important hobby is skiing in the snow. I love skiing. I went to Canada for about 6 months and skied nearly every day. Went traveling, so there's a fair few pictures of me giving the thumbs up, being happy in the snow. So you want to hit the next slide? Thank you very much. So something I actually picked up in Adelaide was I started playing ice hockey. So, there's the one ice arena in town, and I started playing. And so I've been playing for about a year now. That's me with my friends at the Canucks game in Canada when we went to visit.
Oh, wow.
Yeah, it was awesome. They lost, but it is what it is. I enjoy camping lots. So I've been on a road trip around the USA. So there's some pictures of me going around there. Had a car with a rooftop tent went around to a ton of national parks on the East Coast, on the West Coast actually. There's Zion National Park, Arches National Park, and it's memories that I'll take with me my whole life. So I highly recommend that people go and travel and see all the natural wonders of the world, because they are stunning and should be appreciated.
Yeah, that's incredible. Amazing photos. It looks super fun.
Thank you.
Good snow photos.
Yeah. Thanks.
So it sounds like you've always been interested in space from a young age. And you mentioned going to uni, but what did your pathway kind of look like to getting a job at Southern Launch?
Yeah, no problem. So it started when I was 11, and I decided that I wanted to do something in space. I wasn't sure what that was, but I went through school. I really enjoyed physics and mathematics, and I was like, okay, so engineering is kind of the logical path for me. I looked at all of the degrees. I remember UNSW having an aerospace degree, UCID having the aeronautical with the space major, but you can also do the space major with mechatronics and mechanical. So there's other pathways. You don't have to do aerospace. You can do other degrees and pair it with the space major. And there were a few other degrees. There was one at ANU, and I decided on UCID because it was close to home. My siblings had gone there, and he was like, yeah, engineering department's pretty good. He liked the lecturers and the education. So that's how I decided on my degree. And I knew that degree would take me into the space realm. It would provide skills. It would provide the engineering background and the space knowledge of orbital mechanics, rocketry, to kind of enter the space field. Did that for 4 years, so 4-year degree, did it in 4 years. A couple of my friends took longer. They had an internship that took them, it's a part-time study, which highly recommend you do. Take as long as you need to do your degree, don't rush through it.
Yeah, great advice.
Yeah, you can take as long as you want to do your degree, so long as you're doing something on the side, whether it's contributing to an open source project, an internship, something that's building your skills as well as your degree. So I got the degree, didn't have a job because I was very slacking on the application side of things, very busy with my thesis. So I chose a thesis that was relevant to what I was interested in. I was very interested in interplanetary trajectories. And so my thesis was based on Moon to Mars trajectories. I did the preliminary design work for what is essentially a coil gun on the moon to just launch cargo directly from the lunar surface, slingshot it around Earth and to Mars. And so I did a lot of the delta V requirements, preliminary design analysis for that project. And that was awesome fun. And it will link into what I do at Southern Launch. So with that project, I built around this NASA software to do these trajectories for me and kind of just churn through them. So I had data for a period of 2 years and kind of used that to develop these trajectories. And so that will come in handy for my job at Southern Launch. From that, I then went to Thales, Australia. So I went into their systems engineering team in above water systems, which taught me a lot about requirements and the real world of contracting and dealing with a customer and making sure that they have what they want. So that was that was a very important development for me. Coming from university where you're just like, you're kind of given a rubric and you're like, okay, this is how I get the marks. Whereas in the real world, you need to build that rubric of requirements such that the customer's happy, because that's what they want. They want to be happy. They want a tool that fits their requirements, and you need to flesh them out. And so that was really important development for me to understand all of that. And then I applied at Southern Launch. They were advertising for modeling, simulation, and analysis, and applied. Turns out that they have a very similar situation where they have a 6 degree of freedom trajectory solver, and that they've wrapped their own program around that to use that solver to perform simulations. And so when I was speaking in the interview, oh, hey, I've done this, they were like, whoa, this is really cool. This is nice. So that definitely helped me. Yeah, it definitely helped me get a job at Southern Launch and in the space industry, was having a relevant thesis, having relevant experience, going, okay, this is linked to this. I can do this because I've already kind of done in the past. So that's kind of my journey into the role that I'm at right now.
Yeah, awesome. Thank you for sharing that. And there were lots of good insights about uni life and how you can build your skills for a career. So what kinds of things are you responsible for managing at Southern Launch?
Yeah, no problem. So at Southern Launch, modeling, simulation, and analysis is a bit of we do a lot of things. So probably the majority of our role is securing risk hazard analysis permits for space launch and returns. So that probably takes up around 50% of my time developing. So risk hazard analysis, for those who are unaware, basically quantifies and captures the geospatial risk of a rocket launch and return. So the Australian government has this act, and the Space Agency has the Flight Safety Code, and the Flight Safety Code kind of is a guide of how to create these risk hazard analyses. And you do this analysis, you generate trajectories, you perform Monte Carlos to get a statistical model of, okay, if this activity is to occur, these are all the things that can go wrong. This is what can go right. This is where it'll land. These are where debris will land if something goes wrong. You apply probabilities to what event can occur. And then you develop a nice little, like a set of isoplex on the Earth's surface and go, okay, this is where the risk lies. You may have a 1 in a million chance of being a casualty. So that would require an exclusion zone. And so that's what the risk hazard analysis is. It quantifies these risks of these activities.
That's super important.
Yeah, very important. And so that's maybe 50% of my job. Another 10, 20% is probably assisting the sales team. So the sales team, somewhat not technically minded, very good at sales, but they might get a question from a customer and they go, okay, off to the model simulation and analysis team. So it might be a question about the winds ranges. It might be a question about the general weather. It might be a question about, okay, is this trajectory possible given open source data on the internet? And so we will generate those trajectories and go to the sales team and go, oh, here you go, make it look nice. And so they will do that. And so we'll assist the sales team with that. Another 20% is probably preliminary design for some other projects that we've got going on. And so that might be any sort of mission assurance things, developing software to assist with our missions, stuff like that. So that's what a day in the life of the model simulation analysis engineer at Southern Launch. It varies a lot. We get a lot of things just because there's so many things to do at Southern Launch.
Yeah, you guys have been very busy. For those who don't know, Southern Launch has been in the news recently for a few very exciting things, including the successful re-entry and landing of the Winnebago 2 capsule, which marks not only the first commercial return on Australian soil, but the first commercial return to a commercial spaceport anywhere in the world. So did you have a role working on this project, Matthew?
Yes. So that was a very, very fun time in my life. We got this contract and we were like, oh, is it possible to return something accurately from space? And we're doing the analysis and going, oh yeah, this looks really good at the Kaniva test range. The risk fits nicely in our range. We're doing this analysis. We submit the RHA. So that's half of the job done, is the developing the risk, and then you have the actual on-day operations. So I have the privilege of being the meteorological officer. So that's lots of linkages with the Bureau of Meteorology, a lot of linkages with our own forecasting tools, weather balloons, getting that data, putting it into a parameter that says, yes, this is compliant with what we modeled in the risk hazard analysis. Because if it's not compliant with the risk hazard analysis, you haven't captured that risk. And so it's a no-go. So I got to be the meteorological officer, taking all the data from these different sources and then giving my go. My other teammate, Nida Rashid, another modeling and simulation analysis engineer, she got to be the flight safety officer, flight simulation officer. And so she took in the state data that was provided to us by Rocket Lab back then. It was their photon bus. So we took in the data, punched it through essentially a statistical correlation method, and said, yes, this is within the state that we have modeled. So you take a bunch of states and you got this bubble in space And then you've got to say, are we predicted to be within this bubble of space? Because once again, that's, have you captured that risk? And then my team lead, Nathan Drummond, he was the flight safety officer. And so he kind of checking over our shoulder, making sure that we're doing these calculations correct, checking the aircraft, making sure that they're not in exclusion zones, coordinating that whole safety aspect. So that was all happening. The return happened at midnight, the W2 return. And so we were on console from maybe 7 p.m. to about 2 a.m. We were relieved from console. It touched down, I believe, at about 1:30 a.m. So it was a long night, but it was very exciting. You know, you're getting all this data in. We've got this visualizer where you can see the capsule coming in. It's in orbit. And you're talking with Rocket Lab, with Varda. These very, very big companies. Rocket Lab's been around for ages. Varda's relatively new. These titans in the industry, essentially, and you're dealing with these problems as they come up. It's very, very, very fun. Very cool.
Yeah, that sounds like an incredible experience. Did the pressure, did you work well under the pressure, or was it a bit difficult having such a historical return?
Yeah, it got to us a little bit. There was a time when they got on the headsets and they were like, right, okay, this is your last opportunity to go to the bathroom, grab some water, grab a snack, because you're going to be on console for the next 3 hours and you cannot leave. That's it. We went outside and we're all talking the agencies there, and we're talking about what, you know, how awesome this is going to be. Everything's going smoothly so far. And then you sat back down at your console and you're going, okay, right, this is the last 3 hours. The burn's about to be programmed, and then after that, you know, they're querying the ground stations to figure out if the burn went correctly, because the fun thing about space is you can't always communicate with your satellite. So they communicate this burn, they transmit it up to the satellite bus, and then they go, yep, okay, the bus has received it, it's programmed in, and then it leaves the ground station talking range. And so the satellite autonomously computes this burn and completes the burn. But we've got no idea on the ground whether it's been completed well until it is re-entering. It's coming in regardless of whether this burn went correctly or not. And so that was sitting down at that console. I was like, okay, there's this kind of, not stress is setting in, but that it was such a momentous occasion was setting in.
Was it a big celebration when it touched down finally?
Yeah, there was. So Varda got the GPS pings and we were like, yeah, everyone was clapping, everyone was standing up. It was nice.
I can imagine the feeling. That would have been incredible.
The best part was actually, so we had ground stations with cameras so that they could track it, and we had 2 of them. And having them be like, oh my God, we can see this thing coming in. They see the photon bus breaking up and the little debris. It's shooting stars, essentially. And then this long streak of this capsule coming down. It was just hearing them, because we couldn't see it, unfortunately. Didn't have the bandwidth to transmit it back to Hindmarsh, where our operations center is. But hearing them, that was awesome. And getting the pictures afterwards of this capsule streaking across the sky at literally 30 times the speed of sound. It was awesome.
Yeah, incredible. And this capsule has really been significant for the public. There was a BTN episode on this capsule. It came to the Discovery Centre here in Adelaide, and there were many news stations covering it, but BTN, which is a news program for children, covered it, and we still have kids coming to the centre asking to see the capsule, and we have to disappoint them and say it's not here anymore.
No.
It was a one-day thing, but the kids are so excited about this return. So yeah, it was very historic.
No, that's always awesome to hear. At Southern Launch, we're super passionate about STEM outreach. I've gone to a couple of schools and given talks, and it's a huge part of who we are. We really enjoy getting out there and getting people excited about STEM, because we're also excited about STEM.
Yeah, absolutely. Speaking about atmospheric physics, I'm very interested in that. I studied it at uni. So I was wondering, how much can weather change the path of a re-entry or a launch? And yeah, how much do we need to take that into account during these events?
Quite substantially.
Okay.
So when we model this, we grab all this data from the bomb, like 60 years worth of weather balloon soundings and develop a model that says, okay, this is the worst case wind that could ever possibly happen. And then apply that in all sorts of different directions. And then you develop this statistical model that goes into the RHA. And it's huge. The amount, especially for something under parachute, the parachute deploys at around approximately 5 kilometers. And so it's drifting with the wind. The dispersion from wind is huge. That's also not taking into account your space weather. So you have weather up in space. You have winds and atmospheric effects. It can bulge with the sun. It can decrease with the sun. That has a substantial impact on the impact location. And then you've also got your, thicker level atmosphere density, and that leads into your drag and how much the wind affects you. And so it has, if I had to quantify it, I would say about 90% or 80% of the overall dispersion of the risk that we captured was wind. And that was probably, I would say, 200, 300 kilometers in distance. So if we had no wind, we could easily pinpoint where it's going to go, but because the wind is ever changing and so difficult to predict, you can never really guess it.
Yeah, that's very interesting. Yeah, incredible. So maybe we can move on to sort of your advice for people who are interested in a space career. So what are your thoughts on opportunities in Australia as a whole in the space industry?
No, opportunities they're growing. They're coming up more and more. I'll be honest, when I went to university and I was doing engineering, the lecturers, the people were very pessimistic about getting space jobs in Australia. I should preface that. In Australia, they were all like, you have to go overseas, you have to go to Europe, you have to go to New Zealand, you have to go to the US. That is the only way that you're going to get space jobs in Australia. They just didn't exist, 10 years ago. They weren't there. But in the last 10 years, the Australian Space Agency has become a thing. You've got all these companies doing such awesome things in the realm of space that it's exploded. And so the opportunities in Australia is definitely on the up. I never thought that I would be here at an Australian space company doing modeling and simulation. I never thought I would get to do that opportunity. Modeling and simulation has been my passion since my thesis. I was like, oh, this is really cool. Did it, and then I've got to translate that into an Australian space job. It's crazy.
Yeah, we're very lucky to have it in our own backyard.
Yeah, the space agency, it's awesome. Yeah, no, there's definitely opportunities out there. A lot of them are small companies, so they might not be very active on LinkedIn. So you have to look at these space associations. There's the SIAA, I don't know what it stands for, but it's a space association that Southern Launch is a part of. There's a bunch of them, and so you have to kind of do your research into these companies and figure out what they're on about. Does it align with what you want to do? But there's tons of them around. Yeah,
there's over 100 space companies in South Australia alone. So it is a very growing industry.
No, absolutely.
So if some people out there are listening and they're really keen on a space career, what advice would you give to people? Do they have to be good at maths? What kind of skills should people develop?
You don't have to be good at maths. If you want to become an engineer, being good at maths is recommended, but you don't have to be an engineer to join the space industry. I work with lawyers, I work with logistics people, I work with social media people, I work with mechanical engineers whose background is in racing cars, not space. Tom, our mechanical engineer, has helped design essentially a rail for launching rockets. There's so many opportunities out there for people who don't think that they should be getting into, like, they can't. It's like, oh, I'm not good at maths, I can't do anything with space. You can. There's so many opportunities out there to join the space industry, not in engineering. So yeah, but if you are an engineer looking to get into the space industry, I can give you a little bit of targeted advice.
Yeah.
So if you're in university, I would highly recommend joining clubs and societies. So at UCID, I was part of the rocketry team for a semester. That was an awesome experience. A friend of mine started the University of Sydney Space Society. So they designed and built a rover for the university rover competition. So
Cool.
it's those type of skills, those practical experience with relevant tools, employers look upon very highly. They go, okay, this person, sure, maybe great at university, gets good marks, but they've also got that practical relevant experience they can bring to this role. You've kind of proven that you can do it in a working environment, not necessarily a university environment, because the university environment is very different to the environment that you have at work. So
Yeah.
that's the advice I would get. Get as active as you can in the community. Go to these town hall events, start talking to people already in the space industry, because once there's a name to face and people like talking to you, it's a lot easier to contact them and be like, oh, hey, I've just graduated university. They'll help you. If you're a nice person, they'll help you and you'll help them, and that's kind of how it all works.
Yeah, networking is definitely a huge part of the space industry is very everyone knows everyone sort of thing. So networking is definitely important. Did you maybe want to expand on what you meant by the university and the working industry environments being not quite the same?
Yeah, so I was pretty good at university. I studied lots, stayed up late working on assignments, had a really good friend group, helped each other out, and got through the COVID years. But then I went into the workforce, and it's very different. As I was saying earlier, there's no rubric. You might not necessarily know the question that you need to answer, and so you need to first find the assignment that you need to do, and then complete it. And you need to not let not let perfection sit in the way of good enough, because perfection in a commercial sense is probably too much.
Yeah.
If you spent 2 weeks developing a tool when you could have done it in 4 days and have it work in 4 days, but not necessarily be perfect, it's better done in 4 days. And so there's those skills, there's those hands-on experience. I don't do soldering and stuff. That's not my expertise. I did a little bit of in uni, and I knew that I was terrible at it. But colleagues like Oscar and Tyson and Andrew, who are very hands-on with the electronic side, so they've done a ton of electronics for flight computers and whatnot. That hands-on experience, they developed that at university before they started their job, and they developed it doing extracurriculars, doing projects at home. And so it's those skills that you don't quite get at the university level that you have to go beyond to do.
Yeah, absolutely. I have a couple more questions for you, but I might just remind the audience, if you have any questions that you'd like to ask Matthew, now would be a great time to pop them in the Q&A feature, and I will pass them over to Matthew. So maybe the last section I'll ask you about is sort of the future of the space industry. So looking forwards, do you think Australia's role in launches and re-entries is going to expand?
Absolutely. In my time at Southern Launch, I've seen that Australia can provide quite a unique environment for space launch and return. We've done comparisons to the US and Europe in terms of space launch and returns. And Australia, because it's such a large country, it's such a sparsely populated country with large densities of people in the cities and then not much else around, we provide a really, really unique proposition to the space economy, essentially. And so the launch ranges that Southern Launch can provide huge opportunities for other companies to come in and use our infrastructure, use our ranges. And so that's definitely a growth area. You've got companies like Gilmore Space building a rocket and potentially launching a rocket. You've got other companies. There's one in Brookvale in New South Wales, Sydney, that's looking at building a rocket. You've got tons of companies that are doing all these exciting things. And it's growing as we see more and more commercialization in space, as we move away from the model of governments doing rocket launch and more contracting rocket launch. So I see that those opportunities growing, and the space industry in Australia taking advantage of those opportunities because of our unique geographical position and because of the educated people that we have here. People like myself and all my people and all the people that graduated with me from University of Sydney, who were all very pessimistic in year one about, oh, we're going to have to go overseas. We're not leaving the country anymore. We're staying around, keeping that knowledge within Australia. And that will absolutely grow the economy and the space industry in Australia.
Yeah, absolutely. Australia's a great place to do space. And what changes do you think we might see in the next 5 years in the space industry?
So I might be a little bit biased here, but in space manufacturing, I see being quite large within the next 5 years. I think there's, on the back of the Vada re-entries and then proving that you can manufacture something in space and bring it down safely, I reckon that has and will kickstart lots of research into in-space manufacturing. And I believe someone very relevant to the space industry said that within the next 10 to 25 years, everyone will own something that has been manufactured in space. There is just stuff that we can manufacture in space that can't be done on Earth. And as it becomes more accessible, you've got Vada selling, these capsules that go up every 3 months and come back down, and they're looking for a higher cadence. You've got other companies that are also looking at manufacturing in space. Yeah, because there is opportunity, there will be more people looking at it. And so I think that will become a very, very relevant part of everyone's lives in the next 5 to 10 years.
Interesting. Well, we'll have to check back in 5 years' time.
Yeah, hopefully my prediction's right.
Well, I might move on to some audience questions. So the first one I've got here, what has been the most challenging or rewarding moment you've experienced while working at Sudden Launch?
Ooh, okay. So the most challenging was the SR-75 sounding rocket launch. It's a wind-weighted launch. So that means it's very, very wind dependent. And it basically means that you have your launcher, your launch rail, and you adjust where it's pointing, because the rocket that is unguided and statically stable will veer into the wind. Kind of counterintuitive. Think of windmill. It will veer into the wind. And so it'll launch off the rail and then go, and then pitch and yaw across to some direction that you quite possibly didn't intend. And so wind weighting uses this effect to minimize your dispersion. So you say, we're going to say, we actually don't know what the wind is going to do for this amount. You model that in your RHA. And then you do all this analysis on how the rocket will respond to different wind speeds. And so you can essentially point your launcher in a direction and then have it launch and pitch across to back on the nominal trajectory and sort of land where you expect it to be. And so this was very, very nervous for the modeling, simulation, and analysis team. First launch of the SR-75, first use of this software. So we did a ton of testing, but until something's used, it's all theoretical until something's actually done. And so my teammates and I was looped into them as the Met officer in the. So there's two boxes. I was in the box, the MCC, and they were in the wind weighting hut. And so I was giving them all the wind data, and they're doing the calculations to adjust this. And for the last 15 minutes, you can't move this rail launcher. It's pointing in the direction. You've done the analysis, and you say, okay, the wind's not changing, but you're assessing how the wind is changing and if that was within the model limits in the RHA. And so you're watching this line go, and you get a gust and it goes up and it goes near the limit and it goes down. And so that was probably the most stressful 15 minutes of my life.
There was incredibly stressful.
There was a hold at 2 minutes, and the wind limit exceeded. So there was a hold for something else. The wind limit exceeded, and I had to go to the range director. Be like, oh, wind limits exceeded, still exceeding. We're back down, and then the pause came off, and you're just watching this line for the last 2 minutes, and then it launched. And there's footage of the SR-75. You watch it come off the rail and then pitch up exactly as it was supposed to. And so that's probably the most rewarding moment, is watching this theory that we developed that's, done off stuff in the 60s, and then putting it into practice and then going, oh, okay, this stuff actually works. And the software that the team wrote worked. So that was probably the most stressful and the most rewarding experience.
Yeah. Incredible. That's a great answer. Okay, I've got another one. Is there any research ongoing or in the future looking to slingshot something around Earth to Mars and then continuing further beyond the extremities of the solar system?
Yeah, so there's always research around these trajectories. There's a lot of smart people at JPL chucking in these doing these trajectories because they may not appear useful now, but they will probably be useful into the future. So there's always researchers using supercomputers at JPL to assess these trajectories. I'm not familiar with something other than my idea that looks at a direct moon to Mars example and then going beyond. Probably because there's a little bit of hesitation about launching something towards Earth at 5 kilometers per second. So until that gets worked out, I'm not too sure that there's stuff looking at using the Earth as a slingshot maneuver. But there is definitely research probes. I'm not certain on anything commercial that's looking at using slingshot maneuvers, because all the commercial projects that I'm aware are going to the moon at the moment. Don't really need a slingshot to go there. But I'm any commercial commercial stuff that's planning on using that. So
Yeah,
sorry, I
know.
can't help more with that one.
That's okay. Historically, there was the Voyagers, which were slingshotting.
Yes.
And each time they passed a planet, their trajectory just changed.
It's crazy how they did these. They saw this opportunity. A genius at JPL produced these trajectories and was like, we could do this. And then NASA was like, we have to use this opportunity to go to the extremities of the solar system.
Yeah, it's also incredible how differently the two Voyagers ended up. But from the planets that they were affected by, yeah, they've left the solar system now, which is pretty cool. Alrighty, have we got one more question? All right, for someone who is post-university and looking at further training and education, what roles do you think there will be growing demand for in the local space industry? For example, flight modeling, hazard analysis, manufacturing operations, etc.
Yeah, so I'm aware at Southern Launch. We are currently advertising for a model and simulation analysis engineer.
Well, there you go.
So that's definitely a growth sector. I see it as a growth sector because as we get more and more missions, it's a legal requirement that you assess the risk of this activity. We have a duty to the public to make sure that our activities are safe. The government has a duty to make sure the activities that we perform are safe. So that's never going to disappear. So there's always going to be flight modeling and hazard analysis, trajectory modeling from launch ranges within Australia. So that's always going to be around. I don't see that disappearing. Manufacturing design, there is lots of stuff around. You've got Gilmore going on. You've got Black Sky Aerospace, a bunch of other companies that are in the manufacturing. I see Australia going into building products that will go on other satellites, so kind of like Newman Space. I think that's going to be a huge growth area. There's Valiant Space in Queensland, who produce very specialized bits of technology that will be used on other people's things. So I see that as a huge growth area that Australia will take up. On the operational side of things, as launch and return cadence increases within Australia, there will always be operational roles that are required. I believe we're also advertising for a range director. So we're looking at getting someone in permanently to manage our ranges and to manage the operational side of things. And then as we currently, we don't have the cadence to have a dedicated team that's out at Ceduna. We have a dedicated operations team, but they're all out in Adelaide. But as the company grows, that operations team in Adelaide will grow as there's, we get different operations going on. We get, free entry a couple of years ago. No one was talking about it. No. But now it's a huge part of the conversation. So there will always be new types of missions going on that the operations team will always need to build upon, optimize. So that will always be a huge side of it. So those are huge areas. Other areas that I see being growth software. As these companies get more and more streamlined in their processes, they will need software that goes along with that. A good example of that is a couple of ex-SpaceX engineers went, the way that we do integrated countdown sucks. They're terrible. They're Excel spreadsheets and they're really bad. So they purpose-built software called Epsilon 3 that handles all of this stuff fantastically. It's got checklists. It's got, you know, I do the meteorological officer role. I say go. Nathan, the flight safety officer, also needs to give his go. So he will come over, he will check the things and give his go in this software. So it's purpose built for this. We have Magic, which does all of our flight modeling and hazard analysis. It will need to be optimized in the future at some point, as you know, we get to a ridiculous cadence of, you know, maybe 36 launches a year. We currently can't do that. That's not possible. But the team will grow. The software will need to be better, and so there will be lots of software opportunities there in purpose-built software for these companies. So I see that as a big growth area. Structural side of things, we need to build these launch ranges. So we need people who are educated in space, who need to build on-the-ground infrastructure. We need people who are good at networking, like the physical cabling and networking. We have currently, I think, one guy somewhat permanently on it, and another guy who does it part-time. That will be a huge role. Because we got customers coming in with their own things, you've got to make sure that it interfaces. It's a huge role. So that's going to be a huge growth area as we move to permanent infrastructure in this country, because at the moment there's not a lot of permanent infrastructure. It's temporary stuff. So those are the demands that I see growing. I see regulatory growing. You know, the regulation will change as Australia gets better. You will need lawyers on the side of the companies advocating for the companies. You will have lawyers on the side of the space agency advocating for the space agency, and there will be back and forth. And so that's going to be a huge role as, you know, Southern Launch and the country becomes better at what we do. The FAA over in the US has consultations all the time, legal consultations and consultations with engineers, figuring out a better way to do these things. Make it more streamlined, make it easier. So that's going to be a huge growth area. Another one I see is research into the environments that re-entry will occur in. There's not a lot of data on stuff re-entering, because most of the time we want it to burn up. So into the environments that satellites go through, that will be a huge research area that I see a lot of academics becoming interested in. I know a lot of academics are interested in it. And so that's from an academic side. So there's loads of growth opportunities in the industry.
That was a great summary of all the different potential career paths somebody could go down if they're interested in re-entries and launches. Do we have any other questions? You may have touched on this a bit in your last answer, but someone is asking, how is the launch mission simulation process conducted, and what kind of softwares do you guys use?
So I'll touch on the softwares, and then I'll get you to say the question again. But we use Magic, which is inbuilt purpose-built software for risk analysis. For our 6DOF solvers, we use Astos. So Astos is a commercial space 6DOF solver that does launch re-entry and space trajectories. So that's what we use. I know the structures team use SolidWorks. We use CFD to get advanced, very detailed aerodynamics on the vehicles that we deal with. As I mentioned, we've moved to using Epsilon 3. Which is purpose-built software for these integrated countdowns. And for other checklists, you may have checklists for launching a balloon, for example, that we do. So there's checklists for that. What other software do we use? In terms of coding languages, primarily we do things in MATLAB, but there's a little bit of Python. I know a colleague is very into Rust, and so he uses that a fair amount. Rust, C++. So that's the software. And what else was the question?
I think you may have answered it, but it was about the simulations that you guys do. Yeah.
Yeah. So those are the software packages that we use.
Yeah. I think you've answered their question. That is all the time we have for today. Thank you, everyone, for joining us and listening to our space guest, Matthew. And thank you, Matthew, for sharing your story with us. It's been fantastic. For the audience, if you'd like to learn more about space in Australia, you're welcome to contact us or come visit us at the Discovery Centre and join us for our next digital Q&A next month. Thank you very much for listening. That's all.
No, thank you very much for coming. Thank you for having me.
Thank you, Matthew.